So let's talk about Part D. Part D gives you information about a line that's coming at us in a slightly different form than that which we're used to. So D asks you to find an equation for the horizontal line that passes through the point 11, 12. So how did you approach this problem? Side that worked on this one. Say again. What's the one word in this problem description that's not obvious what to do with? Jordan? The x-intercept. Wait, we're looking at D, right?
Oh, sorry.
Yeah, x-intercepts are hard to deal with in general, but here we don't know what the x-intercept is. I think the difficult word is this one, horizontal. So what we need to do is figure out how is this problem giving us the same kind of information that we're accustomed to getting about a line. If I'm trying to find the slope-intercept equation of a line, that's still my ultimate goal here, right, is to land in this box. And so what information I need is I need to know what is its y-intercept, and I need to know what is its slope. But it doesn't look like we're given slope information here, and it doesn't look like we're given a y-intercept either. Instead, we're given just some random point, 11, 12, and also the information that the line must be horizontal. When in doubt, draw it out. And this was, I think, the successful strategy for those of you that I worked with this problem on, is that you first labeled the point 11, 12. We know that our line has to pass through this point. We also know that our line has to be horizontal. So if we don't know what to do with that information, let's just draw a picture that reinforces that information. So I'm just going to draw in this horizontal line that passes through the point 11, 12. So now I have a good picture. So I've kind of moved from the original statement of the problem down into this box, where now I have a graph of this line. And now that I have a graph of this line, in order to determine the slope-intercept equation, I can do the same process that we did before. If we find the coordinates of 2 points, then we know what to do from there. Use those 2 points to determine a slope. Use the slope in one of those points to determine a y-intercept. And we're done. We're only given the coordinates of one point, so we have to find the coordinates of another. What's an example of another point on this line, besides 11, 12?
0.
Yeah, so looking on this horizontal line that's up here, maybe the most convenient point to label is the point which is right there at the y-intercept, 0, 12. Labeling the y-intercept is going to help us down the line because it's going to make it so that we don't have to do the extra step of discovering what the y-intercept is. We know that if this line is horizontal and it passes through 11, 12, then it must also pass through 0, 12. Its y-intercept has to be 0. We could have labeled any other point along this line that we wanted to, but labeling 0, 12 actually has some benefit to it down the line. So let's do that. So our first point was 11, 12. Our second point, we're deciding, is 0, 12. So now that we have the coordinates of both points, where do we go from there? Trying to get from these 2 points to a slope-intercept equation. So follow the yellow brick road. What's the slope of this line? So to find the slope, you'll subtract the y values, you'll subtract the x values, and then you'll divide those results. My denominator here is negative 11, my numerator is 0. What do I get when I divide 0 divided by negative 11? Yeah. By the way, this was a question that I heard from a couple of people walking around. How come this isn't undefined? Under what circumstances would we get undefined instead of 0? Yes, if 0 is in the bottom, this fraction is undefined. So be on the lookout for that. Right. So compare. If this were instead 11 divided by 0, then we would get undefined. And if we got undefined, we would be stuck as far as the y equals mx plus b formalism goes, right? We wouldn't be able to use mx plus b if my m was undefined. Instead, we'd have to resort to a different form of this equation. But In this example, we ended up dividing and getting 0. So my slope is 0. So what's my next step if I'm trying to find an equation for this line? Well, my next step was just to plug in that slope. But if you're telling me that my slope is 0, how do I find my y-intercept? It's already there. That was the benefit in choosing 0, 12 as my other point. Choosing 0, 12 as my other point tells me that my y-intercept b is really what number? 12. And so to finish my equation, all I should do now is probably simplify. What's a simpler way to write 0x plus 12? Yeah, 0x is equal to 0, so we can just get rid of that term and get y equals 12. Let's see if we can come up with a rule of thumb out of this procedure. What does being horizontal tell you about a line?
Your x-coordinate is going to be 0.
Your x-coordinate, well, your x-coordinate is not necessarily 0, but what is true is that the coefficient of the x is going to be 0, and the coefficient of x is otherwise known as slope. So being horizontal means that your slope is 0. Let me flip that question on its head and ask you about this. What kind of a line would we have if it was the other way around? Vertical. So if our line happened to be vertical instead of horizontal, then what would happen is the other case that we saw over here. A vertical line is all rise and no run. Right? No run, meaning that the 0 would be in the denominator, and so the slope would be undefined. So those are what we call the two corner cases, the two cases where the slope is something that's interesting and exceptional. Right? If we get a slope of a line that's 0, that means that that line is horizontal. If we get a slope that's undefined, it means that the line is vertical. And any other slope in between indicates a line which is neither all horizontal nor all vertical, but it's somewhere in between.